Optimizing Queries Part 2 of 2. In this nugget, we continue our trolley ride through the optimization process in MySQL, focusing on queries, of course. Here we're going to look at two specific aspects. First, examining a show command called show warnings. Many MySQL DBAs don't even know this command exists. However, I humbly submit to you that show warnings is a useful command to have in your administrative toolbox. And I'll demonstrate that to you in the upcoming whiteboard segment and the demo. The second portion of this nugget deals with MyISAM index caching. When we consider that the MyISAM storage engine is the default storage engine in MySQL, it behooves us to take advantage of every performance tuning characteristic of said storage engine possible. And index caching is one neat feature of MyISAM that we can leverage in MySQL that can improve the performance of our indexes on the server. Let's get started. First, we have the question, how can we use the built-in show warnings command in MySQL to optimize queries? Well, first of all, what is show warnings? We know that the show commands are useful in MySQL Server because they provide us as DBAs with rich metadata on various and sundry goings-on in our MySQL-D. Specifically, show warnings provides far richer detail on the MySQL parser than we would otherwise get. Now, MySQL parser is that component of MySQL-D that initially intercepts the query that comes in from the thread. Now, the thread is a term that you may or may not be aware of. I hope that you are. Thread is often sometimes referred to as a process, often sometimes affectionately referred to as the connected user. And it's that connected thread that's submitting the query to MySQL daemon. Parser is going to be, if you're familiar with the term parse, when we parse something, we're kind of breaking it apart and attempting to understand it. Oftentimes we speak of trying to parse someone's language to tease apart their text and make sense of exactly what that individual is trying to say. MySQL parser does the same thing when it receives incoming queries from a thread. In this sample code you see in the middle of the whiteboard, we have the statement create table if not exists city, and then we have a column declaration. Notice that the parser comes back with query OK, 0 rows affected, but there is a warning. Now then, to parse the MySQL parser, let's take a closer look at what we have. MySQL-D is going to give you a number of however many statuses it's giving you back as a user or as a thread. And then as we're going to see in the upcoming couple of slides I have for you, you've got three states. You have a warning, you have an error, or you have a note. Now, of course, an error is going to be kind of a showstopper. A warning is somewhere in the middle, and a note is just an informational message. Now, in some cases, the line between an error or a warning is a little bit blurry, because in this case, MySQL is not going to allow you to create the table, and we can see that because if we run show warnings, we get more richer detail. The level here of this warning is actually a note. The code is 1050, and the message of this warning is that the table city already exists. So the take-home message that I'm trying to get across is, without using a command such as show warnings, just running a command to MySQL-D and getting just this generic warning message back, one warning, two warnings, etc., is really telling you a whole lot of nothing as far as why your command was rejected by the MySQL parser. Running show warnings can tell you exactly whether MySQL parser rejected your batch or rejected your command based on a note, error, or warning, can give you a specific status code and a specific status message. Query optimization with show warnings continued. Another thing you should keep in mind with the very useful show warnings command is that show warnings goes into effect and can display warnings both for DML, data manipulation language, as well as DDL, data definition language, SQL statements. Now, yet another neat thing from a query optimization standpoint is that show warnings can reveal the source of invalid or out-of-bound data input. And to bring that to light in an example, let's take a look at some more sample code. Here we're creating a table named T1 that has just a single column of the integer data type that's unsigned, so we're not concerned with plus or minus, but check it out, it's not null, and that was fine. Now the key here isn't the unsigned or the not null, but actually that the col1 column uses the integer data type. Now in the second statement, we're inserting into T1 the value French fries, and we're making that a string. Now, depending upon what your SQL mode is, we covered SQL mode to a modicum degree of depth earlier in the course. MySQL is pretty good about doing type conversions. In other words, if we did an insert of a string literal of, say, 3, that insert would have been just fine. Depending, again, upon your SQL mode, MySQL would have just type converted that 3 into an integer of 3. But if we try doing an insert like this of French fries, forget about it. In this case, we're going to come back with a warning. Now, you might have enough skill to understand, well, that's a typing problem. But just to nail things down, proof positive, running show warnings is going to come back and tell us specifically the level here is of the warning type, code 1366, the message incorrect integer value French fries for column col in row 1. Therefore, really from an educational standpoint, show warnings is good as you develop your MySQL learning curve in your development environment as you create objects and do data inserts and as you design new databases and database tables. I think that show warnings should prove a nice educational tool for you as well as a good troubleshooting tool and a good optimization tool as well. Finally, we have some miscellaneous notes regarding the show warnings command. The first of those notes is that your warning data is volatile. It's held in memory and it's available only for the current statement or batch. In other words, in the previous whiteboard, when we conducted that insert statement and it said 1 warning, unless we immediately run show warnings and get our warning output, that particular warning data is going to go up the chimney and go away forever if we do another insert statement, you see? So our show warnings data is very, very volatile. Be aware of that. Another thing, just to keep track of this, is your 3 error levels formally defined are either error, which deals with an event that will actually stop the processing of your command. The difference between an error event and a warning is that a warning will allow the event to continue processing as long as MySQL is able to do so. Now, a couple whiteboards ago, where I showed you that statement of create table if not exists, blah, obviously MySQL can't create a table of the same name if there's already one of that same name. But a warning will tell MySQL, or MySQL is essentially telling you, I had that backwards, that it will continue processing the statement to its furthest capability. The mildest type of warning is the note, and as I said earlier, this is purely informational. Especially in the life of a busy database administrator, you oftentimes want to filter that kind of stuff out. And at the session level, you can set the variable SQL_notes to 0, and this will filter out and prevent the display of any note level errors or note level warnings. On the other side of the equation, there's a related show command called show errors that will show only those warnings that deal with the error level type. So you can actually cut right to the chase and look at only those warnings that will preclude further processing by the MySQL parser. There's some great articles in the MySQL reference manual. There's one in particular on the show warning statement. And even more than that, there's a great article in the MySQL reference manual that describes all of the fields in the show warnings output. And that one, I think, is worth your while to study as far as real-world application of using show warnings. I've certainly given you, just in these whiteboards, more than enough information that you need to succeed on any questions you see on your DBA2 certification exam. MyISOM index caching. If you have any experience at all as a systems administrator, much less as a database administrator, you know that caching is the name of the game. If we can take frequently accessed data and move it from the comparatively low-speed disk I/O subsystem and move it into the exponentially faster RAM subsystem, memory subsystem, then you right there have dramatically increased the speed of whatever you're doing in that data area. Well, here, as you know, in this two-part mini-series of the course, we're dealing with how we can optimize queries and query performance in MySQL Server. Now, you may know that dollars to donuts InnoDB is going to give you better performance in a transaction-oriented, or as it's sometimes called, OLTP environment. However, you also may know that MyISOM is the default storage engine in MySQL, and if you do much consulting, you may walk into a lot of shops where the IT departments don't know any better, and they've already invested and been locked into a MyISOM solution. Or maybe, frankly, you just choose to stay with MyISOM for its speed and durability at the expense of no transaction support. Now, to that end, how can we maximize indexing performance with MyISOM tables? Our exam objective now deals with index caching with MyISOM. What you should know is that MyISOM offers the strategy of caching or buffering index information. It's called the MyISOM key cache. And by default, all of your MyISOM tables are stored, or at least a portion of them, are stored, as many as can be fit reasonably, in this MyISOM key cache for frequently used access and increased retrieval, or decreased retrieval time, I guess is what I should say. And this size, the size of this cache, this RAM cache, can be customized with a system variable called key buffer size. Those are the two main points I want you to know, that we can cache MyISOM indexes by modifying this RAM cache called the MyISOM cache, and we do this by tweaking up a system variable in your option file called key buffer size. And here are the permitted values down here. It's a numeric value. The default size, you give the value in bytes. The default is only 8 megs, but you can actually crank that up to 4 gigabytes if you want. If you want to go into the reference manual and research how to bring that out, I mean, if you're on a 64-bit architecture, as you know, your server may have a lot more than 4 gigs of RAM. But that's a pretty large index cache, quite frankly. Now, more on tweaking the key cache. We do need to know how to set this up. How do we create table-specific key caches? In the previous whiteboard, I said that out of the box, you have just a single buffer, a single box, shall we say, a RAM box, into which all of your MyISOM tables wind up getting dumped as they're opened by users. However, for performance, you may want to create table-specific key caches. You may have a particular MyISOM table that gets hit especially hard by users. So you've got your default cache for most of your MyISOM tables, and then you've got a super-duper cache that's devoted to your super-duper MyISOM table. Well, how do you do that? Creating a custom key cache is a 3-step process. Let's take a look at the 3 steps. The first step is we create the cache, and in this example, we're creating a cache for the world.country table, and this cache is called country_cache. So to create a 6 megabyte cache, you just run from MySQL client set global, the name of the cache, dot, and then this variable should look familiar because we already introduced it, and then you set the size of the cache in bytes. Second step, you assign the cache to the table. Cache index, name of the table, in, and then the name of the cache. And then once you've attached the cache to the table, you load the table's existing indexes into the cache. Load index into cache, world.country. So that's how you do it. Now, the caveat to this is that this procedure is going to expire at server restart. So in the next whiteboard, I'm going to show you how to make this configuration persistent if, for instance, we always wanted to have a specific key cache for, in this example, the world.country table. If we wanted a table-specific MyISOM key cache for a certain table, in other words, just a persistent configuration, again, it's pretty straightforward. It's a two-step process. First thing we'd do is we'd create a text file called server.init in the root of our data directory that contains those preload statements that we made in the previous whiteboard. Simple as that. Very basic file. Second thing we would do is that we would map in our option file to where that server init exists. Now you can have more than one run of preload statements in your server init because you may very well want to create more than one cache for more than one table. Bottom line, you'd have one server init in your data dir, and then in the MySQLD portion of your MySQL option file, you'd put in a directive called init-file, and then you would simply path out to the location of your server.init file. And then every time MySQLD starts, server.init is processed, and you've got yourself table-specific MyISOM key caches. What do you think about that? In our demonstration, we're going to do three things, not two. I'm going to put in an extra bullet point. You may recall from the previous nugget, there were two leftover items of business. One, we're going to do a little ditty on show process list. And the other thing we're going to do is the general query log. We enabled those logs in the previous nugget, but I never got around to showing you their contents. So once we take care of that old business, we're going to get into the current stuff, which deals with examining the show warnings in all of its real-life glory, and then we're going to work with configuring MyISOM index caching. Without any further ado, let's fire up MySQL. We're going to work in Windows this time around. Our first order of business in this demo is to ensure that we've enabled the general query log. We're on WinNugget 1, our Windows Server 2008-based MySQL server. I've got a lot of this stuff pre-prepared, as you can see. Pop open our my.ini configuration file, and in the MySQLD section, you'll see I've already added the general _log directive. And also, in the name of preparation, I've run net stop MySQL and net start MySQL to restart the MySQLD service. Therefore, I now, at this point, have the general query log running. What I don't think I told you in the previous nugget is when you create a general query log or enable the general query log, you wind up with a new file in your data dir that picks up the host name of the server .log, okay? Now the general error log is the name of the server, which on this server you can see I actually have not renamed the server. I've been referring to it as WinNugget, but the actual name of the server is win-qndy blah blah blah. Looks like I have a little bit of homework to do. This is actually a fresh server. Once I log into my SQL client and begin executing queries, we're going to see another file show up with this wonky host name .log, and it will in fact be a plain text file. Let me demonstrate that to you really quickly. We'll log into the MySQL client as root, and we'll just run a couple queries. We'll use the world database, we'll show our tables, and we'll select star from city. If we come back to our data dir, we see a new file here. Again, it's the host name of the server, .log, and we can double-click this guy and open the file directly in our text editor, Notepad. The file is not all that pretty to look at. I'll give you a nice hint. Although the exam objectives, the MySQL exam objectives, do not cover the graphical tools, if you're not using the MySQL Administrator free graphical utility available at mysql.com, you might want to consider downloading it. Some MySQL administrators poo-poo the graphical tools, saying, well, real administrators use the command line client. Well, that's all well and good, friends. But the MySQL Administrator tool includes a really nifty log file viewer that can make it much easier and easier on the eyes, quite frankly, to view some of these logs, including the general query log. because we're just looking at the naked log, and believe me, over time, your eyes are going to cross taking a look at this, you see. You see, we've logged in as root, and we've selected a particular database, world. You notice that it is echoing everything we're doing, not necessarily command by command. Sometimes the parser is putting it in its own language. But ultimately, we are echoing DDL and DML commands. It says one query, show tables, and then finally one query, select star from city limit 5. Therein lies the rub, so to speak, in the general query log. The slow query log works the exact same way, only it's going to echo only those slow queries. The binary log, again, basically the same thing, only it's capturing inserts, updates, and deletes. And you have the added benefit of being able to roll back data in a data restore scenario. Good deal. Now then, let's come back to our MySQL client and catch up on another order of business, and that is the show process list command. I mentioned that as long as you're a super user, you can see all threads that are connected to the server. Now, you don't actually have to be a super user or an all privilege holder like root to see everybody's processes. You have to have the process permission. So you can actually delegate this ability to an ordinary MySQL user. If you have an assistant DBA, for instance, you would simply just grant the process permission to that user. And the output of the show process list command is exactly as you see here. It's a fairly simple table. If you're coming from Microsoft SQL Server with Activity Monitor, you're used to this kind of display, but you're used to being able to click and view properties and so on. It's not quite that touchy-feely. Remember, a thread is essentially a connected user. You've got thread IDs, which are unique identifiers for those threads. The user and host, remember MySQL user identities are associated with a user and a host and a port. A default database, if there is one. If a user comes in and is not using a specific database, this will just show up as null. The MySQL Reference Guide has an excellent article that I want you to read that describes all the possible command options and state options. You don't need to memorize those for the exam, but depending upon what a thread is doing, here it's pretty straightforward. As you know, I'm doing query commands. My state, in terms of what my thread is actually doing right now, most of the time you'll find, frankly, if a process is just sitting there, if a thread is just sitting there, the state is going to be null. But if you're in the middle of doing a long insert, it might show a different state. But there's a great article, like I said, that gives you all the possibilities for command and state, the time that you've been doing that particular command, and then info gives you the specific query or the specific command that is being run. And this can be helpful if you've got a really complex query that's going on. And that's really all there is to show process list. With no further ado, let's jump right into the rest of this nugget, starting with show warnings. And the example I'm going to give here comes directly from the MySQL reference manual in their show warnings syntax article. And this is going to be a good example here dealing with queries and showing how show warnings can kind of take us down not the primrose path, but actually the troubleshooting path to writing tighter queries and optimizing those queries. All right, so the way this works is we're going to create a table called T1. First column is going to be called simply enough A, using the tinyInt data type, not null. Pretty straightforward. Second column is B, and we'll make this char4. And then here's where the warning's going to come in. Now, you probably know in MySQL 5.1 we use the engine declaration to denote an engine. There's a deprecated keyword called type, and that's what I'm going to do now. And I'm going to say type equals MyISOM just for grins. Now it tells us query OK, one warning. And it's like, okay, did we create the table or not? What happened? Let's say show warnings, \G. And it tells us the syntax type equals storage engines is deprecated and will be removed in MySQL 6. Please use engine equals storage engine instead. Okay, so we can verify that the table did go through by running show tables, and T1 was created. All right, so the level was warning, which, as you remember before, I told you in the whiteboard, the warning means that the MySQL parser will continue processing, and it did. It created the table, but it gave us the importance heads up that we should start using the engine keyword instead of type, because as of MySQL 6, type will officially go the way of the dodo. Cool. Next thing we're going to do is run an insert into this table. As you see here, I'm inserting 3 rows, 10 MySQL, null test, 300 open source. Can you see any possible problems based on our table definition up here? Let's submit this. All right, so we get query OK, 3 rows affected, 4 warnings. Let's take a look at those warnings. Show warnings. Data was truncated for column B at row 1. Column A cannot be null. Out of range value for column A at row 3. Data truncated for column B at row 3. Well, that makes sense. And the reason why that's so, of course, is because of the column declarations in the table. Column A was a tiny integer. And look what we did in the inserts. We tried to insert 300 in column 3. We also did a not null for column A, and we tried to insert null in row 2. Column B, we did char 4, but we tried to insert 5 characters. So depending upon your SQL mode, you may have had to blank it out in order to get this to work, actually. In this case, let's just take a look and see what happened. We'll select star from T1. It looks pretty ugly indeed. But the point of this, of course, isn't to give us live workable data, but is instead just to give us an idea of how show warnings works, and is meant to give us a deeper picture of what goes wrong in our query and in our DDL DML processing. Finally, let's go through the steps on creating a table-specific MyISAM key cache. Let's verify that the world.country table in fact uses the MyISAM engine, right? That's pretty important. We can do that a couple different ways, actually. We can run show create table country, and we have engine equals MyISAM. That's cool. You'll remember that to create a table-specific MyISAM key cache, there's a 3-step process. First, to create the cache, we run set global, and then the name of the cache. I'll just use the name of the cache from the whiteboard. I'll say country cache. Then we set that parameter key underscore buffer underscore size to whatever value in bytes that you want. So I'll use that 6 megabyte size that we specified in the whiteboard. All right, so I've created that 6 megabyte cache now called country cache. The name's arbitrary. Second step is to assign the cache to a specific table. We could say cache index world.country in country underscore cache. The response, message OK, that's what we want to see. Table is world.country. The operation that just happened is assigned to key cache. Now that's all well and good. We've created that umbilicus, that link between the cache and the table, but nothing actually happens performance-wise until our third step, where we load the world.country's indices or indexes into the cache. And that's just as simple as saying load index into cache world.country. And the operation there is called preload keys. Message text OK. There you have it, friends. Optimizing Queries Part 2 of 2 review. In this nugget, we continued our journey on optimization in the query process of MySQL. I showed you a really handy show command, show warnings, and its related cousin, show errors. I hope that if you weren't familiar with this tool prior to looking at this nugget, you now are a great fan of it. I sure know I am. Provides us such richer feedback than you see normally with the MySQL client. In the second part of this nugget, I showed you how to speed up, in some cases dramatically, MyISAM-based index performance by A, customizing your existing default MyISAM key cache, and B, breaking out your key cache into table-specific caches. I hope that this has been informative for you, and I'd like to thank you for viewing.